I'm going to give you an easier to understand explanation of a thought experiment by physicists called the twin paradox and the concept of time dilation. Basically, there are two twins on one star or planet, and one travels at a great distance and a great percentage of the speed of light to another star or planet, and then he returns. When he returns, he finds that he does not age as much as his brother on Earth. There are many variations on the parameters of this thought experiment. The twins have different names. Sometimes there is acceleration involved. The traveling twin travels at different speeds. Sometimes he travels to a star of different distances. My version, we have twin A and we have twin 1. Easy way to remember that is Earth has the letter A in it, and think of spaceship 1. The Earth and the red planet are not moving with respect to each other. There's 20 light years apart from Earth to the red planet. The green ship is moving at 50% of the speed of light. And the clocks of both planets have previously been synchronized to start at the year 2000, January 1st. In this animation, I put the years so that you can see at the start of the year 2000, twin 1 leaves his twin, and it takes 20 light years for the light to reach the red planet. The twin 1 is going 50% of the speed of light. And then when he returns, it will be 80 years have passed on Earth. Also, you will notice that as twin 1 is getting farther and farther away, if he looks behind him, he sees older and older information. So it looks like twin A is aging slower on the way back. On the way back home, he is seeing newer and newer information. So it looks like his twin is aging faster. But also there is a time dilation because he is going 50% of the speed of light, which I will talk about in a minute. This animation is from Wikipedia under time dilation. It shows that moving clocks move slower than a stationary one. This has been proven with the atomic clocks on the GPS satellites have to be synchronized. But if I could stop the animation right there, the red satellite is moving with a velocity, which means that the direction is in this direction at that moment in time. Gravity is what's causing it to fall towards the Earth and be in a circular orbit, but it is not the cause of the time dilation. Looking again at my example of the twin paradox, the very first moment I said that the green ship was instantly traveling at 50% of the speed of light. In the previous animation, a GPS satellite would typically go 7,000 miles per hour, but every moment of that satellite is the same as the starting moment of this example. So gravity has nothing to do with time dilation. It is purely a matter of speed. In this animation, I have added another planet that is in the same reference as the Earth, and the light has already been traveling through space. This is the reason why the twin who is traveling a percentage of the speed of light and comes back ages less, because he has to get back to the Earth that all the light was destined to get to in the natural course of time for the Earth. Einstein's laws of relativity state that we cannot go faster than the speed of light. We cannot even go the speed of light. And the reason is because we are made up of electromagnetic waves, and you cannot travel faster than the waves we're made up of. In this animation, I have put twin 1 on the green ship going 100% of the speed of light, which is impossible, but he would be ageless. He would not be moving. He would not have the thought to stop at the red planet. We need light to go through us, to age us, to change us. Light causes all change. Since we can't go exactly 100% of the speed of light, we'll do the next best thing and go 99.9999% the speed of light. At this super slow motion, we can see the wave of light refreshing the atoms in the ship, spinning the molecules in his head, signaling the computer to control the ship, and we have aged one moment in time. Here's a graphic from Richard Wilson, PhD, who teaches relativity at the teaching company. A question always comes up: if you can add the speeds from a ship that is going 80% c, or the speed of light, relative to the Earth, and a smaller ship inside this huge ship is going at 80% the speed of light relative to the big ship, do they add up to 1.6 times the speed of light? And the answer is no, because we're made up of electromagnetic waves. This ship is traveling at 0.975% of the speed of light. This bigger ship doesn't matter. The small ship doesn't know it's inside of a bigger ship. It doesn't give it any extra boost. This animation demonstrates the previous graphic, but instead of one giant ship and a smaller ship inside, I have two green ships in the same frame of reference. The black ship overtakes the green ship, and nothing is moving faster than the speed of light. In this animation, we're launching 7 twins. Twin 1 is now going at 90% of the speed of light. When Twin 1 reaches the red planet, Twin A will be 22 years old. When the Twin 7 going at 30% of the speed of light, Twin A will be 66 years old. And the pilot's ages age as well, because not as much light is passing through them. Twin 1 will have aged only 8.72 years, and Twin 7 at 30% the speed of light will have aged 19.08 years. In this animation, I've added some more ships and planets, but due to animation difficulties, these light rays are moving too fast. They should all be moving the same, so we'll just say that these are weeks and these are years. These ships are in the same system as the green ship. They're rigid with each other. They may as well be bolted together, and they are all aging slower with respect to the Earth. These two planets with the Earth are in the same frame of reference, so they are all aging the same with each other. This is also what the makings of a light clock, which I will now talk about. This is my light clock animation. The main thing I want to show you about this is a triangle is created up to this event, back down to when the light goes back into the green ship. We know that the speed of light is constant for everybody from all directions, and so scientists have found that they can use the Pythagoras theorem to prove that time must be slower for a moving observer, because from the Earth's point of view, this length is longer than the light going here, and we know that these distances are the same. Here we have the Pythagoras theorem, and then there's the time dilation equation that was based upon that. It's really easy to understand once you plug in the numbers, but T prime is the time of Twin 1, T is the total time of Twin A on Earth, times the square root of 1 minus velocity squared over c squared. In my example, v squared was 50%, so that would be a 0.5 over c squared is 100% of the speed of light, which is 1. So we don't really need this, because anything over 1 is just simply velocity squared. So if we plug in the numbers, we get 80 total years have elapsed for Twin A on Earth, which means that 69.28 years have elapsed for Twin 1 on the spaceship. Now, if we divide this by 80, we can find out and divide this by 80. Then we have 0.866 is for twin 1, age is 0.866 for every 1 unit of time. And this could be 1 year, or it could be 1 day, or 1 second. And if we square this side and we square this side, we come up with, my formula is t prime squared plus velocity squared equals 1.